Hello, hi everyone, welcome back to the channel. So today in this video lecture we're going to be solving this problem, rotate image. So in this problem we're given a 2D matrix, a square matrix of dimensions n cross n, where n represents the number of rows and number of columns. We have to rotate this matrix by 90 degrees clockwise. So we have to rotate the image in place, that is we can't allocate another 2D array and do the rotation, we have to do it in place. So let's see how we can do that. Let's better understand the problem statement using an example. So here you can see that we have a matrix of dimensions 3 cross 3 containing integers 1, 2, 3, 4, 5, 6, 7, 8, 9. It is rotated by 90 degrees clockwise. So it becomes 7, 4, 1. The first row becomes the last column. The second row becomes the second column, while the last row becomes the first column. Fine. So that's what we have to perform in this problem. So let's see how we can do that. So the intuition to solve this problem is simple. Since we have to do this in place, there has to be some trick to solve this. So just try to figure out some tricks. Just play with this given matrix and you will find it. So let's see how we will find out the trick. So you can see that, notice that what we are doing here, let's just find the transpose of this matrix. Okay, so find the transpose of this matrix, that is rotate this matrix around this main diagonal. So if I do so, all of the numbers which are above this main diagonal will come below this main diagonal, while all of the elements which are below this main diagonal will go above the main diagonal. So the resultant matrix would be 1, 4, 3, 2, 5, and here we would have 8. Then we'll have, like, we have to swap this 7 with this 3, so we'll have 3. Then here we'll have 6, and here we'll have 9. So what I did is simply perform the swapping operation. So here 1, 0 is swapped with 0, 1. So 0, 1 is swapped with 1, 0. Similarly, 2, 0 is swapped with 0, 2. Okay, and so on. Fine. So this will give me the transpose of the given matrix. Now, what is the difference between this transposed matrix and this resultant matrix? We can see that, so this 7 is like there, here we have 7. Now we can see that the very first row in this transposed matrix is 1, 4, 7, while in the resultant matrix it is 7, 4, 1. And the second row is 2, 5, 8, while in this resultant matrix it is 8, 5, 2. In this transposed matrix we have 3, 6, 9. Here in this resultant matrix we have 9, 6, 3. So we have to reverse the rows of this transposed matrix. So if I reverse the rows of this matrix, so if I reverse the very first row, it would be 7, 4, 1. Then I reverse this row 2, 5, 8, it would be 8, 5, and then 2. Then I reverse this matrix, this last row, that is 9, 6, and 3. Now this is the answer matrix or the resultant matrix that we have here. You can see that 7, 4, 1, 7, 4, 1, 8, 5, 2, 8, 5, 2, 9, 6, 3, 9, 6, 3. And that's all. What we have to do in this problem is just around the main diagonal, rotate this matrix, that is find the transpose of the matrix. After that, reverse each row of the matrix. Fine. Now let's see how we can implement the solution. Okay, so like here in this case, first of all I will simply find the transpose. So to find the transpose, let's say I will iterate over each row of the given array. So starting from row number 0, then 1 and 2. Now for each row I will start iterating over the elements. Like for row number 0, I have to start iterating for all the elements from this element itself, that is element number 1 in this row. So from this element I will swap this element with itself. Then I will swap this 2, that is at 0, 1 with the element at 1, 0. Then I will have to swap this element at 0, 2 with the element at 2, 0. like with this element. Then in the second row, I have to start from the first element, like from the second element of this given row, that is from here. So I will have to start from j is equals to 1. Here I had to start from j is equals to 0, because I will swap this 5 with itself, then I will swap this 6 with this 8, okay, and in this fashion I will find the transpose for this matrix. Now for the third row, I will have to start from j is equals to 2, like from this element, because all of these elements are already swapped. Fine. So let's just implement the idea. Find the dimensions of the given matrix. Okay, now iterate over each row of the matrix. Now for each row, iterate starting from the row number, so j less than n, j plus plus. Now swap the element at ij with the element at ji. Fine. Now after finding the transpose, reverse each row of the given matrix. So iterate over each row of the matrix, and for each row iterate till the middle of that row and swap the element at ij with the element at I n minus j minus 1. So finally we'll have our rotated matrix. Let's just see if it works. Okay, so it got accepted. Let's just submit this problem. Okay, so it is accepted. So let's discuss the time and space complexity. We can see that we are traversing over this matrix twice. So here we are traversing over this matrix here once, and then we are traversing over the matrix here. So the time complexity would be big of n cross m, while the space complexity would be big of 1, because I'm doing this in place. Okay, so that's all for this video. If you like the video, then hit the like button and make sure to subscribe to the channel. So stay tuned with me. I hope to see you all in my next video.